Ladies and gentlemen, welcome to another session of the Nambani Academy. We are currently running a series of videos under rates of reactions. It's a grade 12 content. Thank you very much for your support. The numbers are definitely showing that we are growing as a channel. We'll really appreciate that. Tell a friend, subscribe, be on the lookout now for everything that we do. Remember now, this is part 3 of the videos that we are recording for rates of reactions. Kindly watch video 1 and video 2 so that you can have a nice synchronized information of what we want to do. So today the focus is on how temperature affects rate of reaction, as well as how a catalyst also affects rate of reaction. So we are going to take the two factors and try to interlink the two. So we without wasting any time, let's get into it to try and explain. So what I am going to do is I am going to take it back to kinetic molecular theory. And this is a grade 10 topic. One will ask, why do we need to understand the kinetic molecular theory? Because I am interested in particles are always in constant motion. I am interested in that. Particles are always in constant motion. So particles are always moving. So let me add a beaker for me to be able to explain this. I am going to have my particles that are going to be in this reaction vessel. So they are always moving, and now the other part is they are always now colliding with walls of the container. This is now in grade 10. My interest now has shifted to say, because they are always moving, can I introduce a Bunsen burner to this particular reaction? And how will this now influence the particles themselves? Think of a water in the kettle. As the temperature is low, you don't see any bubbles appearing. But once the temperature is increased, you start seeing the bubbles of particles moving around faster. So the kinetic molecular theory explains that. So it basically says, once I introduce now more of temperature increases, what will this do? This will not be specifically looking for this particle A, particle B, particle C, particle D, and particle E. It will only be interested in the overall kinetic energy. So temperature increases. This is very important. The overall kinetic energy of the particles. This is very, very, very important. So the overall kinetic energy of the particles increases. Overall kinetic energy of the particles, I must write here for emphasis that it increases. So this comes from grade 10 to understand what will be the influence of temperature in what? In the reaction phase. So it is just going to increase now the overall kinetic energy of the particles. But in video 1 and video 2, we explained the Maxwell-Boltzmann distribution curve. So when the examiner says now use the kinetic or the collision theory to explain the influence of temperature, the key critical thing to understand is temperature increases the overall kinetic energy of the particles. So this must be what we call our bullet 1 in terms of answering. So this is our bullet 1 when the examiner is asking about temperature. So we need to tell them, and we need to be sure which factor is the examiner assessing. If the factor is temperature, believe you me, the first bullet should be temperature increases overall kinetic energy of the particles. That is very, very important. But there will be other points that we add. The points now that says at a higher temperature, the average kinetic energy of particles increases. So obviously you will need to check whether there was an increase or a decrease in temperature. So obviously the decrease will be the opposite. It further says more particles have sufficient or enough kinetic energy. I want us to add here and further say the more particles have sufficient kinetic energy, which is greater. I want us to add this greater than activation energy. This will assist and help us when we look now into the Maxwell-Boltzmann distribution curve. Because remember we said Maxwell-Boltzmann distribution curve, it is what? It is an energy distribution curve. So that us emphasizing that yes, we are going to have more particles with enough or sufficient kinetic energy, but that kinetic energy must be greater than activation energy. Why? Because it is going to give us what we call more effective collisions per unit time. So when you give your answer, kindly note the word more effective collisions per unit time is important. We said per unit time is a measure of rate. So you need to tell the examiner to say, examiner, me understanding that according to collision theory, particles must have sufficient kinetic energy, particles must collide with correct orientation, which will lead to more effective collisions. That is very critical. Then you will be able to get your 4 marks when the examiner says, explain using the collision theory. So with that being said, what do we have? Higher temperature, higher kinetic energy for all the particles that are in the reaction phase. Furthermore, what else do we have? More particles with sufficient kinetic energy that is greater than the activation energy. More effective collisions per unit time, then it means the rate of the reaction is going to increase. So rate of reaction is going to increase. That is very, very important. But I wanted to take you back from grade 10 for you to understand that particles always have that constant motion. So the constant motion leads now to us having the kinetic energy. So when we heat the reaction vessel, we are not specific in terms of which particle are we heating, but we are interested in the overall kinetic energy of the particles. Hence, the first statement is at higher temperature, the average. So this average, we also call it, this average, we also call it now overall kinetic energy. So that is now how temperature affects the rate of reaction. Increase in temperature increases the overall kinetic energy of the particles. More particles have sufficient kinetic energy, which is greater than the activation energy. More effective collisions per unit time, rate of reaction increases. So this will assist you when answering those questions of increase, decrease, or even remain the same. So that is what you need now to be looking into. But we said we want to explain the energy distribution in terms of the Maxwell-Boltzmann distribution F. So let's look at a situation where we have a temperature T2 which is greater than T1. Let's look at the graph now of T1 that I am going to highlight now with purple. This is the graph now of T1. It says now T1 has a lower temperature. So what does that mean? It basically says T1 having a lower temperature, we are going to have now less particles with sufficient kinetic energy. That is the reason why when you check the area, I'm going to highlight it also in purple. When you check the area of T1, we have smaller or less particles with sufficient kinetic energy. So less effective collisions per unit time, the rate of the reaction decreases when we look at T1. So the hint is the one with greater temperature will always now shift to the right. Maybe I should just commit and say graph with high temperature shifts to the right. This now is a hint that I must just share. That is the reason why when we look at T2, I'm going to make it yellow, or let's make it green. When we look at T2, which is now the green one, we are going to have more particles now. Remember, it is this area of green together with this area now of purple. So we are going to have more particles with greater kinetic energy than the activation energy. More effective collisions per unit time, and then the rate of the reaction increases. So the hint here, like I said, it's now the higher the temperature, the graph thereof will shift to the right. So these are few hints that one needs to look into. These are few hints that one needs to follow in terms of ensuring that we understand how the collision theory works in terms of explaining the effect of temperature on the rate of reaction. So with that being said, I believe we have now exhausted the information in terms of temperature. We can furthermore look into the effect of a catalyst. The effect of a catalyst on reaction rate. The first bullet says a catalyst provides a path of lower activation energy. So I am going to take it back to grade 11, where we speak now of a mechanism for a catalyst. Mechanism for a catalyst. What did we say? We said if I have my reaction here, this is now for an exothermic reaction. This is for an exothermic reaction. This is part of the content we did in grade 10, grade 11. Kindly check the video also under the rate and extent of reactions, where we explain all these graphs. We said if I am going to introduce a catalyst will now lower the activation energy, because this section here represents my activation energy. And this part here at the top, this one here, it's what we call a transition state. Unstable transition state between the reactants and the products. So with that being said, this is now us adding a catalyst. So adding a catalyst, what does it do? It lowers the activation energy. So when the activation energy becomes lower, it means the particles now have an alternative pathway for them to be able to reach the formation of products quicker. So hence it is important to say the catalyst provides a path of lower activation energy. I must remind you again to say, what is a catalyst? A catalyst is a substance that increases the rate of the reaction without undergoing any permanent change. So the mechanism is it lowers the activation energy. After the activation energy has been lowered, then it basically says we have now an alternative pathway. Instead of going up the hill, we can easily take the red path and be able to reach our destination quicker. So with that being said, it says we are going to have more particles with sufficient kinetic energy, which is greater. I need to emphasize this, which is greater than activation energy. That is very, very important, because now we are going to have more particles with sufficient kinetic energy that will use this alternative path that has been created. Then more effective collisions per unit time, and then the rate of the reaction increases. So basically, from the definition of what is a catalyst, it becomes easy to understand that a catalyst will, in most cases, increase the rate of the reaction. We have a positive catalyst and a negative catalyst, but that is not what the CAPS document want us to be emphasizing on. The only thing that we are interested in is a positive catalyst that increases the rate of the reaction. By how? by lowering the activation energy, by creating an alternative pathway, by now giving us more particles with sufficient kinetic energy, which is greater than the activation energy. Because of that, more effective collisions takes place per unit time, and then the rate of the reaction increases. Can we associate this now to Maxwell-Boltzmann distribution curve? Definitely we should, because remember, Maxwell-Boltzmann distribution curve is an energy distribution curve. We explained in part 2 that we are going to have our activation energy before the catalyst, which is going to be the uphill according to the mechanism of the catalyst. But if we add a catalyst, what does it do? It decreases the activation energy. So what will that do to our Maxwell distribution curve? Activation energy with a catalyst, we start now seeing this shift towards the left. So once we add a catalyst, we expect now the shift to the left. Shift to the left. So this shift to the left is only because of addition of a catalyst. We are going to lower, like we did say, when we move from left to right, our activation energy increases or kinetic energy increases. But when we move from right to left, we are going to have a decrease. That's the reason why we say by decreasing the activation energy. So our activation energy now with a catalyst, which is this section, is going to shift towards the left in order for us to get now the lowered activation energy. So be on the lookout to say these are some of questions that examiners usually ask. Explain the shift in terms of the graph. Is it shifting to the left, to the right? What will be the factor that is being assessed? So basically, remember to associate now that the effect of a catalyst together with the mechanism for a catalyst, how actually a catalyst operates. That's the reason why the two should be now interlinked with each other in order for one to be able to fully understand. Ladies and gentlemen, with that being said, I believe we have explained now the effect of temperature on the rate of reaction. We have explained now the effect of catalyst on the rate of reaction. We incorporated now the previous knowledge from grade 10 of kinetic molecular theory. We also looked into grade 11 where we explained the operation or the mechanism that a catalyst uses in order to increase the rate of the reaction. Ladies and gentlemen, thank you very much for watching. Remember to subscribe, tell a friend, and this is just part 3 of the rates of reactions. We will be now quickly recording part 4 and part 5 so that we'll be able to know that everything that is rate of reaction related, we have tried to address the misconception. But basically remember, you need now to watch video 1, 2 and 3 in order for you to have a sequence of events, in order for you to understand the build up to everything that we intend on achieving specifically on this topic. From me, Mr. Nambani, thank you very much and have a lovely day.